MechDesigner, getting started, building a cam mechanism. This is a basic cam mechanism with a rotating cam track that drives a pusher with a cam follower and a mechanism that connects the two. This video gives the steps needed to design this cam mechanism. First, it is important to understand how you should approach mechanism and motion design with MechDesigner. In MechDesigner, you first design the motion for the tooling device that interacts with the product or packaging. Here the motion is designed for the pusher. You can then design and build a mechanism, and finally add a cam. MechDesigner automatically calculates what is known as the inverse kinematics. In this way, the motion of the tooling is always the same and is preserved throughout any design changes to the mechanism. Alternatively, if the motion design of the cam follower is carried out first, and followed by adding the mechanism and tooling, then this is called forward kinematics. In the case of forward kinematics, you'll find that if the mechanism design is changed at any time, such as the length of a part, the motion of the tooling will also change. MechDesigner does not stop you designing your mechanisms with forward kinematics, but we strongly recommend you to design the motion of the tooling first. Before we start the design, what do we need to sketch in the mechanism frame to locate and align the mechanism parts? We need a line to align the slideway for the pusher. We need a point to position the pivot bearing for the cam follower mechanism. And we need a point to locate the center of the camshaft. So we need 3 sketch elements in the base part to locate and align this cam mechanism. Let's start at the beginning and add a mechanism to a plane. For convenience, let's hide MotionDesigner using the Show Hide MotionDesigner icon. Then spin the view in the model graphic area so we can see the planes. Then we use the Add Mechanism command in the Model Local toolbar, and then select a plane in the graphic area, and then click OK in the Command Manager. We then have a new mechanism, as shown, with a Mechanism Local toolbar to the left of the graphic area and the Mechanism tab at the top of the Mechanism graphic area. As noted earlier, we need 3 sketches in the mechanism frame, so let's edit the base part to add sketch 1. Double-click the base part outline to open the part editor and start sketching. We can now add a line to the base part for the slide rail. Click the Add Line icon and click and drag the line out. Dimension the line as is to begin with, using the XY axes of the part. Dimension the line so that it turns black from blue, and then it's fully defined. We can then edit the dimensions precisely using the Edit Dimension dialog. Double-click a dimension arrowhead to open the dialog, then right-click the dimension value to open the 0 or round drop-down. Round changes the value to the nearest number that is exactly divisible by the number shown in the lower field. Repeat this a number of times to round all the numbers that you've used to dimension the line. Here, I round and then also change the dimension using the spin box. Exit the part editor by clicking the Edit Part icon. You are now back in the mechanism editor with a Mechanism local toolbar to the left of the graphic area and the Mechanism tab at the top of the graphic area. We are now going to add the slider with a motion to the mechanism. Use the Add Part command to add a part for the slider. Click and drag the line out to add the part. Use the Add Sliding Joint command and select the line along the added part and the line we have drawn in the base part, and then the parts will snap together, or the lines will snap together. If we drag the part outline, we can see it has 1 degree of freedom remaining. We add a motion dimension function block to define that remaining dimension. The motion dimension function block requires 3 elements to be selected. We first select the rectangular joint symbol, and then we select a point in the new line sketched in the paste part. And finally, we select a point in the sliding part. We can then edit the motion dimension function block to locate the slider a bit more precisely. As with normal dimensions, we right-click the dimension value and choose Round, and then define the value and click OK. Then add a motion to the slider. Select the motion function block and place it in the graphic area. We also need a linear motion function block to drive the motion function. We then connect them together by dragging a wire between the function blocks. When we use the cycle command, we can see the slider move with a motion in MotionDesigner, a stroke of 100 mm. We are now going to edit the motion for the slider in MotionDesigner. We will change the stroke of the slider from 100 mm to 30 mm. Use the Show Hide MotionDesigner command in the toolbar, and then select the motion segment with the position we want to edit. Then use the Position Value spin box to reduce the value at the beginning of the segment to 20 mm. Then select the next segment, and again use the Position spin box to reduce the position of the beginning of this segment to 30 mm. Use the Show Hide MotionDesigner again for convenience, and cycle the machine. Now you'll see the slider moves with a new shorter motion as designed in MotionDesigner. We are now going to edit the slider to add a line. Double-click the slider to start the part editor. Click the Add Line command and drag out a line in the part. Fully define it using a combination of dimensions and constraints from the part local toolbar. 2 dimensions and 2 constraints later, it is fully defined and the sketch line turns black. I'm going to fast forward to accurately position the line using the Edit Dimension dialog. This time I double-click the Y-axis of the part to exit the part editor. Here I'm going to add a line for the mechanism grounded point. Double-click the base part again to open the part editor and add a dimension, a new line in the base part. I'm fast forwarding here because we followed these steps before. Finally, I exit the part editor. We are now going to add a simple mechanism to the slider. In the mechanism editor, select the Add Part command to add 2 parts. You may notice that 1 pin joint has been added automatically as we added the first part. Then use the Add Pin Joint command to join the 2 parts together and to the slider. Now when we cycle the mechanism, the slider effectively drags the other two parts along. I'm now going to add a line in the base part to define the center of the camshaft. Fast forwarding to save a little time, because we've done this many times already this tutorial, I'm going to edit the base part by double clicking on it and then add a line and dimension it, and dimensioning it using the XY axes. We now have the line in the frame ready for the camshaft. We are now going to add a part to represent the camshaft. In the mechanism editor, select the Add Part command. To automatically add a pin joint as we add a part, hover over a point so it turns red before clicking and dragging out the length of the part. With the part added, add a motion dimension function block. Again, 3 elements need to be selected. Here, a pin joint, a line radiating from the pin joint in the frame, and a line radiating from the pin joint in the added part. Click OK in the command manager. We can define the angle of the camshaft at the start of the machine cycle by editing the motion dimension. Let's make the angle 90 degrees from the horizontal. There are now 2 motion dimension function blocks, one to represent the slider motion and one to represent the angular position of the crankshaft. If you use the same linear motion function block to drive them both, then the motions are synchronized, so that when we use the cycle button, you can see the slider and camshafts complete one cycle in the same time. We are now going to sketch a cam follower. We're going to add a cam follower to one of the links driven by the slider. Double-click on the part outline to start editing the part. Our cam follower will be round, so add a circle to the part. Select the Add Circle command and drag out the circle. Dimension it in the usual way, the diameter, and then using the center of the circle and the XY axes to locate it in the part. The circle will turn black. I'm going to round all the numbers as usual while we fast forward. Exit the part editor by clicking the Edit Part command. Before we use the Add Cam Track command, we must convert the sketch that will be used for the cam follower to a profile. Select the Add Profile command in the Mechanism local toolbar. Then select the circle which we have sketched for the cam follower. And finally, click OK in the command manager. Finally, we are going to use the Add Cam Track command. Select the Add Cam Track command in the Mechanism local toolbar. We need to select the camshaft and the cam follower. Select the camshaft we have already prepared, and then select the cam follower. Finally, click OK in the command manager. The internal and external cam tracks immediately appear. We can cycle the machine again to watch the cams rotate to drive the slider with our motions, as designed in MotionDesigner. We have now completed the Add a Simple Cam mechanism with some inverse kinematics and with a simple motion design in MotionDesigner.